Okay, class, today we're going to be doing some review from our polynomials unit. So going way back to second trimester. And when we're looking at polynomials, we're really not going to talk about all of the different properties, but they will come up in some of what we're doing as we review here. But we're really going to be focusing on multiplying with polynomials. And our biggest focus is going to be multiplying binomials times binomials. But we are going to have to review some of the other things before that. So we're looking at multiplying polynomials. Okay, so some things that we want to remember is that when we multiply with exponents, we actually add the exponents. Okay, so that's a piece, oops, hit my paper there. That's definitely a piece we need to remember. And we also need to remember the distributive property. Okay, so the basic piece that we need to be okay with is if we have something like 2x squared times 3x to the third plus 5x squared minus 7x. Okay, we know that these parentheses tell us to distribute, and that's even something that we sort of reviewed on when we were looking at reviewing solving equations, right? And so we're taking this number out here in front, and we're passing it out to each of these through the operation of multiplication. Okay, so we're going to look at each one individually and multiply. So we want to take 2x squared times 3x to the third. So we multiply the big numbers in front because 2 and 3 function like they always have. So 2 times 3 is 6. And then we add the exponents. So 2 plus 3 gives us x to the fifth. Okay, and then we will move on to the next one. So then we will say 2x squared times a positive 5x squared. Well, 2 times a positive 5 is a positive 10. And then we add the exponents. So 2 plus 2 gives me an x to the fourth. And then we go on to the third one. So our third one says 2x squared times a negative 7x. So 2 times a negative 7 is a negative 14. Now remember, if we don't see an exponent at all, there's really an exponent of 1. So 2 plus 1 gives us 3. And so our final answer is 6x to the fifth plus 10x to the fourth minus 14x to the third. Now remember, that is our final answer because we cannot combine like terms if their exponents don't match. So don't try and take this any further. We can't add any of those up because those exponents aren't the same. Okay, now we then took that a step further and we said we could do something like multiply 3x plus 7 times a 2x minus 5, right? And we could multiply a binomial times a binomial, okay? And when we multiply a binomial times a binomial, we are still using that distributive property, but we need to distribute for however many numbers are sitting in front. So since a binomial is 2 terms, we're gonna have to distribute twice. So the first thing that we'll do is we will distribute the 3x. So 3x times 2x, right? I'm pretending this 7 isn't here at all, and I'm just distributing that 3x. So 3x times 2x gives us a 6x squared. And then 3x times a negative 5 gives us a negative 15x. Okay, and then we're just going to flip-flop. So now we're going to ignore the 3x, keep that sign with the 7, and we're going to distribute the 7. So a positive 7 times a positive 2x gives us a positive 14x. Now you could write that positive 14x, just tag it along, or you could recognize that it's a like term and write it underneath. That doesn't really matter. That's just sort of a preference of how you visually like to see it. A positive 7 times a negative 5 is a negative 35. The key, though, whether you write it horizontally or you sort of stack them up, is that then we need to remember how we add and subtract polynomials. So when we're adding or subtracting, we need to combine things that do have like terms. So since these are both x's, there are things that we can combine, right? So we need to make sure we're getting like terms combined. So we'll have a 6x squared. A negative 15 plus a 14 is a negative 1x. You could write the 1, but it's not needed. And then minus 35. So the 6x squared minus 1x minus 35 is our final answer. Now, once we remember how to do that, we then have to recall some of those special situations. So let's say we want to take x plus 8 and multiply that times x minus 8. So if we remember the fancy word for this, these are called conjugates, right? Because one's a positive and one's a negative. Okay, otherwise they look the same, but the process of multiplying is still the same. So we're still taking this x, because there's two terms, we're ignoring the 8 and we're going to distribute. So x times x is x squared, not 2x, right? We're adding the exponents and those each have a 1. Then we'll take x times a negative 8, which is a negative 8x. Okay, then we'll flip-flop and we'll go to the other one. So a positive 8 times an x. Now I'm just going to write this the other way just because I know some of you have different preferences, so I'm going to write it over here. Positive 8 times x is a positive 8x. And a positive 8 times a negative 8 is a negative 64. Again, we still have to make sure we get like terms combined. So right here we have like terms. So a negative 8x plus an 8x is a 0x. So we don't need to write that down at all. Those just go away and we're left with x squared minus 64. Okay, one last unique situation. This is the one I swear I always want to hit you guys over the head. I would never actually do that, remember, but, right, let's say we take something like 5y plus 3 squared, right, where we have the binomial and it has that exponent of 2. Remember, an exponent of 2 always tells us to multiply something by itself. So our rule on this one was that we actually needed to write this twice. So we needed to write out 5y plus 3 times another 5y plus 3. Because once we wrote it like this, then we went back to the same thing we've been doing and we could just start distributing. So 5y times 5y gives us a 25y squared. Okay, and a 5y times a positive 3 is a positive 15y. Right, and then we'll start distributing the 3. So a 3 times a 5y is a positive 15y. And a 3 times a 3 is a 9. So we'll have 25y squared, again combining like terms, plus 30y. When we add, we do not add the exponent, so that stays as a 30y, plus 9. And that will be our